Success in PCI injection is not just about pushing more coal. It must be measured against a broader set of KPI. And what are those KPI? Now, as you can see, the coke replacement ratio is our key economic driver. But we must also track furnace productivity, stability, and quality of hot metal slag. Higher as from coal can alter slag chemistry. So, alkali removal capacity must be monitored. And this is a multi-dimensional challenge. Now coming to the PCI system and coal properties. As you must be knowing, a stable pneumatic conveying is non-negotiable. Pressure fluctuation reveal flow instability which can derail operation. So coke quality matters, grindability, petrographic, volatile content, and all of affect combustion and coke replacement in a big way. The hard proof grindability index must match our mill capabilities. We are not just injecting coal, we are engineering a controlled reactions. So coming to our raising PCI rates, we shift the furnace operation state. As we all know, like flexible power plant, we need robust instrumentation and control system. A raft adiabatic flame temperature drops the coal injection but can restore via oxygen enrichment. Every kg of coal injected must save coke efficiently. Top gas temperature rises with the PCI, so heat flux must be managed to protect equipment. Now coming to the in-furnace phenomena and risk. High PCI rate generate unburned char and fines which degrade permeability. Coke quality becomes critical, higher CSR and abrasion resistance are neglected. Body distribution must adapt to maintain gas flow and with elevated heat load, a step temperature must be monitored to protect furnace integrity. So this is where the science meet vigilance. Now, pneumatic conveying stability, as you must be knowing, this is the main vertebra lifeline of the PCI system. Now, stable conveying prevents tear blockages and ensure symmetric fuel distribution. It improves combustion efficiency and create a controlled environment for data analysis. So, without stability, we cannot isolate the effect of PCI increase. So, this is the foundation before any coal reaches the raceway. The flow must be predictable and uniform because unless until it uniform, symmetry of the furnace operation cannot be ensured. Now coming to the flexible operation and control of PCI. And we know that PCI increase is not just a fuel change, it's a shift to flexible operation that demand a control strategy capable of handling a new dynamics, faster race reaction, slower burden descent, and increased thermal stress must be anticipated. So monitoring 2 years steps refractory lining becomes very essential, and control logic must evolve with the processes also in order to combat the anticipated changes. So now coming to the focuses on in-furnace phenomena, but upstream factors also, which are the real bottleneck. Unstable fuel feed will doom the project before it start. So pneumatic stability is a measurable KPI. The pressure fluctuation must be tracked. Coal cutability and grindability determine whether our mills can meet the increased demand or not. So this is where the success begins. Now coming to the unburnt char and coke quality. Unburnt char is the hidden enemy. Particle size distribution governed burnout efficiency. Finer grind means better combustion. As PCA increases, coke rate drops. So remaining coke must be stronger We cook bricks into fines, combining with char to choke permeability. Coke quality is not optional, it's a survival. Now coming to the raft and combustion focus. We know raft is very important, and raft is not just a temperature, it's a dynamic reaction zone. And combustion zone especially focus with the VAM oxygen enrichment combination of both. So advanced lances help control flame shape and dispersion. We must balance gasification and combustion to maximize the reducing gases while avoiding soot and instability. So this is a precision combustion engineering. As far the raw material and fuel quality is concerned, PCI coal properties, VMFC, ash, sulfur must be optimized. As we know, as fusion temperature affects slagging risk and moisture must be below 1.5%. Particle size must hit 80% below 74 micron, and coke must have a high CSR and consistent sizing. Every input affect furnace stability, and effects are amplified at higher PCI rates. Now coming to the injection and combustion system, so monitoring pressure fluctuation, we have to keep a huge control to ensure the conveying stability. A raft must stay within the target. Oxygen enrichment always help, but we need to corroborate all these with respect to object temperatures. The two-ear camera detect the blockages and soot. The top gas dust reveal also the unburned char, and these diagnostic our eyes and ears. So efficient combustion start with the reliable delivery and end with the complete burnout. So the furnace stability and performances is concerned, the permeability and the gas flow are key, and pressure drop and K factor reveals flow resistance. Hot thermal state is tracked via hot metal temperature and silicon, and body descent must be smooth. We should not forget. Sleep signals instability, and we have to keep a huge distance from such type of occurrence. Cooling system heat losses indicate channeling risk, and these are the vital sign of furnace health. Now coming to the process efficiency and product quality, top gas analysis like CO, CO2, hydrogen shows a reduction efficiency. Temperature must stay above dew point. Coke replacement ratio is our economic KPI. Hot metal sulfur and slag chemistry must meet specifications. PCI ash alters slag composition, so basicity must be controlled. And this is where efficiency meets metallurgy.